All right. Avoiding Windows Store app crashes and hangs. Not avoiding Windows Store apps, like it said on the front slide out the front, which is kind of embarrassing. I'm Andrew Richards.
Martin van der Bospoort.
And we both work up in Seattle. Tell us about yourself, Martin.
I'm a principal consultant in Premier Services, Premier Support for Developers. I have a dotted line to the Windows PC ecosystem team, and I help ISVs and third-party developers write quality apps for next version of Windows. So to that extent, I had the opportunity to write a book with Jeffrey Richter. It's about the WinRT API. If you're familiar with other books, Jeffrey Richter, he tries to stay away a little bit from the UI. Then that gives them a real nice opportunity to deep dive into the APIs. So the book, similar as to his CLR book, is a deep dive into the WinRT, into the WinRT APIs that I wrote with him. That's about it. A little plug here for Premier Support for Developers. So I have a dotted line into Windows, but my background is a consultant in Premier Support for Developers. We help ISVs and third-party developers write quality code for Windows. So if you find yourself struggling with getting up to speed on the latest techniques, need help, need an account manager inside of Microsoft, then follow that link there, or come talk to me after this talk. I can help hook you up and use those facilities that we have in Premier Support.
I'm Andrew Richards. I'm the host of Defrag Tools on Channel 9. Anybody watch the show? We got any really big fans out there of Channel 9? Let's see if I can find some swag. Let's see what I've got. Haha, I do have swag. Bribes. All right, I saw. All right, so there's something special about today. Does anybody know what's special about this date today? That too, which is probably more important than what I'm about to say. It's someone's birthday. Do you know whose birthday it is today?
Someone?
Now, Channel 9 was Monday. That's 10 years. Bigger than that. Microsoft. Do you know how old today? 1975, so 39. So Microsoft's about to have its midlife crisis. All right, that's all the swag I've got. Channel 9, I do a weekly show. It airs every Monday morning, 9 a.m. Roughly, it's this talk every week. It's about something that is to do with troubleshooting or performance or something like that. I think the episode on Monday is episode 85. We cover lots of diversity, sysinternals tools, debugging tools, you name it. About, when was it? Around Christmas time, I did a 10-part series on every single major store app issue that we've seen. And this talk is an abbreviation of those 10 episodes, which is maybe 8-10 hours. And this is an abbreviation that's more store-centric and endemic issues. And I also have a talk at Tech Ed in Austin called Hardcore Debugging, which goes into more of a debugging approach to it. So watch those episodes if you want more information. Who I am is when your PC crashes, you know how you won't go send to Microsoft? Comes to me. So there's 3 of us on my team, and all crashes come in for Windows, phone, and Xbox. I'm in charge of user mode crashes. Another guy's in charge of user mode hangs, and another guy's in charge of bug checks. And so I write software that analyzes that, and I write Bang Analyze, which some of you guys might know about. All right, agenda. So there's a couple of phases to working out why things are failing and what you should be doing about it. How do you actually even know your store app's failing? Well, there's telemetry that we provide. We're going to go through some nice hexadecimal debugging. I don't do a talk without some nice hardcore level stuff, and show you how to debug to root cause. And then we'll go over the mistakes that we see endemically in the ecosystem. Because we have all the data coming in, we can analyze at scale what people are commonly doing wrong. So what we want you to learn is understanding what quality means as far as apps concerned, how to debug it with WinDBG. Unfortunately, you can't do it with Visual Studio right now. And we're going to look at some code.
So the first part, the first part here is The first section of this three-piece talk, how to actually get to your failures, right? So once we have our failures, then Andrew will take us off the cliff, do the deep dive with WinDBG. Let's see. I need to go.
7, I think it is. There we are.
Okay. Most of you know where this is. Just for level set here. If you go to your Dev Center, you log into Dev Center, you go to the dashboard. We look at the click rates, and the click rates are not super high. Where you want to go to is of course, for an application. You go to your particular app, and then you go to reports. However, before I go in here, there's one little thing that you need to set in your account as well. In order for us, or actually for Andrew, to get the data, you need to be, your app needs to send us that data, and you need to specify that in the portal. When this comes up, it will give us a checkbox somewhere where we can say, send us the data once it comes in. There we go. Here is telemetry data collection. You need to make sure that the box is checked, otherwise that data does not come from end user's machine to us, and we have no data to give back to you. Going back to the actual reports. If I go to my app and I don't have a humongous amount of crashes, I'd love to say that it's because of the quality of my app, which is partially true. There's not all that many downloads, is the real story. If you go to the details of this thing, of the quality, you'll see there that we have three sections. We have the JavaScript exception rate, which well speaks for itself. If my app is a WWA app, WWA app written in JavaScript with HTML5, then if it crashes with an exception, this is where it would show up. A crash is a crash. I have an exception somewhere, shows up there, and the last one is an unresponsive rate is a hang. We'll look at the last two categories. We'll look at the crash rates, and we'll look at the hang as well. And as a matter of fact, we'll look at it in a background hang.
And this is where you download the file. That download on the right is the file that I'm going to be debugging. So we show you the top 5 issues that you have for your app and give you a sample cab. That's a real cab from a customer that's come to us. We've made sure that it's PII stripped, so there's nothing in there that's dangerous, and then we give it to you, and you get 1 copy of each of the top 5.
So two sections. There's the Windows Store apps that I just showed you here, but we also have the phone apps. It has a dashboard. It's similar. It's not identical, but you can get your crash data from there as well. Here is an example of a more populated app where you can see the JavaScript exceptions, the crash, and the unresponsive, the hangs. If we switch back to my machine here, just to show you what you would get for a Windows Phone app. So instead of downloading the actual cab file, you download an Excel file, which will give you the app, an app ID, some other information. It will give you an exception type, and then also a stack trace. And all the way at the end, there's actually a link to a cab file as well. So here is where you can download the cab file for Windows Phone. So it works similar, not identical, but once we have the cab file, then Andrew will show you what to do with these
What magic you can do.
machines. Back to there. So here's the Windows Phone apps from the portal, and now
Debugging it.
debugging.
So just so I level set here, who's used WinDBG? That's good. So I haven't got time to go over what WinDBG is. The simple gist is download the Windows 8.1 SDK. When you run the installer from the web, you get lots more options that say roughly giving the compilers, the code, the header, but there's other options for the debugging tools for Windows, Windows Performance Toolkit, Application Verifier, and a couple of other things. Install the debugging tools for Windows. You need to install both the 64-bit and the x86 edition because you need to be the same architecture as the dump file. So if you get a dump file from an ARM or an x86 box, open the 32-bit edition of the debugging tools on your 64-bit machine and 64 and 64. So why is this speech even happening? Well, we've been looking at this crash rate for Windows Store apps since Windows 8 and looking at the debuggability and realizing that the story is really, really bad, right? And what happened in Windows 8 is we released roughly version 1 of the idea and we gave out quality reports. We made this blog post that says roughly use WinDBG in these certain ways. But we came to the realization that we actually can't really get to root cause. And so what happened is in 8.1 and also an update to Windows 8.0, we introduced a thing called stowed exceptions. And what that means is when the exception comes up through the WinRT, goes in through the language projection layer up into your code, whether it be JavaScript or C# or native C++, there's a mangling between the WinRT or marshalling between the WinRT and the real language. So like, for example, the CLR has system.exception. Well, that concept doesn't exist down at the bottom. And so what we had to do was marshal this extra information available up at the language level, but marshal it in the WinRT space, which is where the exception's caught and where all the dump files and stuff are made and all the reporting's made. And so up until March, that's the way the state of play worked, but we realized that we were missing cases and we were scratching our head, and then we worked out that when we triaged, I've got an NT debugging article about that on the previous slide. When we triaged these dump files, sometimes the data from above the language projection layer was missing. And we had to work out why. And then we realized that sometimes we're not packing it into the triage dump file. And so we invented stow exceptions version 2. And so there's 3 different error mechanisms out there. So depending on what your client's using, you'll get 3 different types of dump files coming in. And the version 2 actually was scheduled for Windows Update. Windows 8 Update just came out, or coming out. But we actually shipped it early. We shipped it in March. And it applies to both 8 and 8.1. So it's a Windows error reporting technology rather than a WinRT technology.
Anyone heard about stowed exceptions before?
All right.
Go on.
So let's get into the nitty-gritty of it. So what I'm going to do is show you debugging all 3 types. We're going to start with the basic of Windows 8, which also kind of applies to desktop, and then we're going to move through to version 2. So when we open a dump file, and we'll just open a random crash type one, what I've got here is, where are we? For example, when I open up a straight Win32 crash file, what we want is the path to be set to the Microsoft download server using this syntax. And you'll see there's an ECXR. So whenever you see ECXR in a dump file, just follow it, always. Never not do that. Just as a general rule, do that. Because it changes it from when the dump was taken, which is like many, many frames away from where the exception was, and brings you back to where the exception was thrown. So in this case, we now see that there's an instruction pointer of zeros being accessed, and you get an access violation. If you want to find out about what the exception part is of this exception code, exception record, the command is ECXR-1. And so here you can see the code. And then based on each code, you get a variable number of parameters, sometimes nothing, sometimes 2, sometimes 4. You get the gist. So in an old desktop world, this is how you do things. Any crash, you do it this way. It's also how you did it in 8.0. So in 8.0, when a WinRT program crashed, it called a function called co-originate exception. And all it does is pass an H result and a H string, which is a OLA string, marshals it across the layer, and then you'll find it in this stack. And quite frankly, if it's a stack of a store app, which this is not, then you still can't find it. You just won't find the data. Same thing goes with phone. This is a phone app running on an ARM device. If we look at the exception here, this one has the magic number for CLR exception, which actually in ASCII is CLR if you change it into text. And because it's a CLR exception, we can use SOS. SOS is the debugger extension for CLR. If you get the Windows 8.1 SDK, it will automatically download SOS from the Microsoft symbol server for you, match the version with the bits from the dump file, and then automatically load it. And so you can see that with .chain. You can see it automatically loaded out of my symbol cache. Because of that, you can run a command called bangpe and print out the exception. This one is a target invocation exception. I'm waiting for some symbols to resolve. And then because this one's got an inner exception, we should follow it. And so you see the sub-exception that was caught by a try-catch handler. Someone made a new exception, attached it as an inner exception, and then threw the outer. And so you can see the inner one was a XAML issue on the phone, or some navigation issue on the phone, with it using the reflection APIs to propagate it through. So that's the old story. When it comes to, I'm sure I'll do the slides for a sec. When it comes to, so that's the old story. When it comes to Stow exceptions version 1.0, you get the error code C000027B. And that's the only error code you'll ever get from a store app from now on. And what you have to do is understand how to twiddle this purple stuff in the middle. And so the way you do that is to do a whole lot of mumbo jumbo with pointers. The failing of Microsoft here is we never documented this at all, internally or externally. And what you have to do is cast it to a header type to work out what the structure is, and then you get this 5345 mumbo jumbo in the signature. Turn that into ASCII characters, which is SE01, Stow exceptions version 1. And once you've got that, you now know that how to determine the type to cast the pointer to. And it's all very complex, right? It's all hexadecimal, it's all yucky. I'm not going to do it on stage as a manual example. You'll get SE01 for version 1. So instead of casting the pointer to the header type, you now can cast it to a V1 structure, and similar for V2. Now, in our ultimate wisdom, we released the private symbols of Combase because we knew we hadn't done the documentation. So for version 1, you actually get private symbols from the Microsoft symbol server and can do this debugging. Because in version 2 we went, this is not very good, we documented it on MSDN, but because we documented it on MSDN, we now only ship public symbols. Great logic, right? So you can do this with version 1, but you can't do it with version 2. So then you spit out the array. Exceptions come with an array of exceptions. And then you get to a point where you get all these mumbo-jumbo internals. Roughly there's two forms. There's a form where you can get a string representation of what went wrong, which is just like a random string that could have anything in it. Or you can get a stack representation, and that's what this DPS command does. And then here's the text representation. Now, this is all way too complex, right? It's not something you want to do every day. There's too many pointers to follow, too many variants. And so the answer is I wrote a debugger extension. Because the documentation is now public, I could privately do this. And so if you go to the Defrag Tools website, there's a SkyDrive associated with the TV show where there's lots of code samples and stuff like that. There's a debugger extension called PDE, which is my prototype debugger extension. And then there's a command called DSE, display stowed exception. And this guy knows how to do all this magic. And because the MSDN documentation is public, I actually wrote the whole thing without needing symbol support, so you can do it with no symbols at all, right? You can do it symbolless. So what will happen is it'll print out all this stuff nicely for you. So instead of doing it by PowerPoint, let's do it by actually seeing it in WinDBG, because that's more fun. So for example, this is a StoreException version 1 crash. It was a store app that crashed. Here's all the pointed to the information, and it has one StoreException within it. And then what we can do is use PDE to print it out all very nicely. And so what you'll see in a vast majority of store apps is this co-originate language exception. And it's this language API that got added to 8.1 that's packing the CLR exception into the exception bubble that's called iRestrictedErrorInfo, and then projecting it into the dump file. And that's how you can get to it. And so the stack you see at the top isn't really useful. You're seeing roughly the marshalling. But what you do get is the error code. And if the error code matches the error code of the last CLR exception, the debugger extension will print it out. So roughly what we're seeing here is this TechReady TV app crashing because it got a null reference while doing authentication, and you see all this magic of it throwing it to WinRT for then finally to be shown. When it comes to StoreExceptions version 2, so this is all the dump files you'll see since March, it's a bit more, it's deterministic. So before, it was probabilistic that we haven't done a garbage collection of the last exception yet, and thus you can get to it. Now, we actually deliberately go to the CLR and pack that memory into the dump file, guarantee it to be there, and associate it with the exception. And that's what the difference is between version 1 and version 2, is this move to a deterministic storage. And so in this case, you can see the marshalling of the error. Once again, it's a language exception. And in this case, it was a not implemented exception. And you can get all the way down to the function name. Now, because this is a CLR dump file, well, the metadata in the CLR process is enough for us to reconstruct this stack without symbols. All right? So download it from the Defrag Tools website. You guys can work it out. It's on the front page. And all you have to do is open up a dump file and type bang DSE. If there is no StoreException in it, it will say there's no StoreException. If there is one, it will give you the nice report. Version 1, as I said, will show this last CLR exception matches result because it correlates the two. And StoreException 2 will say it's an associated result, so you know the deterministic nature of it. All kind of clear? That's kind of complex, I get it, but roughly, bang DSE. That's what it all comes down to. All right, go Martin.
Okay. So, you now know where to get your failures, if you didn't know that already. You now know what to do with those failures in WinDBG. When Microsoft Andrew gets all those failures, we put them in buckets, we analyze them, and then we can see how much of the different failures we get in different scenarios. So you have here a whole list of CLR exceptions. These were, well, it's CLR, so there's no JavaScript in here.
1, 2, 3, 4, 5, 6. It's 13, that's right. This was going to be called top 10 failures, but then we say, well, we've got to call it top 13 because you can't leave not implemented exception out of the list, right? I mean, you've got to have not implemented included any statistic. And it just shows you that, 1% of all crashes coming into Microsoft are because you didn't write some code, right? You need to really be thorough about what you're doing. Null reference exceptions at the bottom, pulling in nearly 20%. Standard thing, check your pointers. XML exceptions high. Why is it high? Well, people have written a lot of RSS feeds and things that talk to like a food website or something and pull down recipes and stuff like that, and they're just assuming that the XML's parsed right? So the XMLs are high in the list. System-type exception is high based on actually an artifact of the CLR. Sometimes when you cast a specific exception and the way it goes through the marshalling inside WinRT, it unfortunately gets cast down to a system.exception. exception. And we actually have an example of that where you should be getting an XML exception, but you get a system.exception. exception. So you do get some generic buckets like that. Interrupt com exception, that's when you're going between like C# and C++. We see that a lot in between C# apps that are calling into C doing DirectX. So when you're not, even though we have Windows compliancy, it doesn't mean that DirectX on the GPU has the feature that you expect from a compliancy point of view. So you try to do a textual render and the GPU comes back saying not supported. And then you'll end up with a common exception. Invalid operation, that's just calling things that invalid at that point in time. Unauthorized exception, local disk, web calls, all that type of stuff. Sockets and net.web exception, simple HTTP traffic. We also get the WinRT namespace, the Windows.networking, whatever it is, namespace as well. People tend to be using the legacy CLR way of doing HTTP rather than the WinRT way of doing it. Argument out of range, negative values on an unsigned number, stuff like that. Argument null, kind of a safer version of null reference exception. And argument exception, we write that kind of a lot. And then, as I said, we couldn't leave out not implemented exception.
Any idea how many of these we get?
How many dumps we get?
Yeah. Can you say?
I can't say. It's statistically broad. So we trace everything actually, so all through development as well. So like all the beta bits you guys have, all that's tracked. So we track every single SKU versus every piece of hardware versus every single thing you can think of. And so we have balances of everything. All right, so I think no reference. Is it you or me? You want to do it?
Yeah, it's me.
You can do it.
This is going to be interesting. It's going to be somewhat painful, the first couple of exceptions. They are so trivial that for a 300 level talk, this is, we had a demo for this, but then we thought, well, let's skip the demo. So null references, as you noticed, it was one of it's the first on the list, right? It was
yeah.
The 20% one. We've all seen a null reference, right? So in this case, you have a display widget function that takes an argument foo get first widget. Well, if you don't check if foo is 0 or foo is null, then yeah, you will crash if you don't catch that exception. So most of these will just be very defensive programming. The next one, really similar. Okay, you've passed that first foo, you know that it's not null. Now, which one is this? Oh yeah, what do I get back from my function call? If you don't catch that, then it's a null reference, but now it's an argument null reference, right? And I think we have the last one. This one we see a little bit more often, and it's
I think this is the common one.
This is the common one, yeah. Where you we get a collection, and then we get a null back from our widgets, right? Yes. So the get widgets returns null. You start iterating over that widget, but since it's null, then yeah, you will again crash with a null exception.
Yeah, and we also get a lot of this type of thing with link, a lot of link queries that you're operating on a null collection set.
Right. So again, no demo for this one.
I
think this is sufficient. But since it's so high on the list, we had to, for completeness sake, we had to put it in there.
Yeah. Now that list predominantly is just exceptions that were missed. If you miss your exception, you are going to crash. It's as simple as that. We all know try-catch blocks are there for a reason, right? Now there's some philosophy around it about whether you do it broad, you do it narrow. Those things are not really things that I'm going to give you as a design pattern. But all I'm going to say is you need to be aware of your try-catch state. You need to be aware of a pessimistic approach to exceptions. If you make an HTTP call, I will guarantee you when you've got 1 billion users, someone will fail. Right? There will be DNS issues. We've seen websites where, www.bigcompany.com, the entire website went offline. And then for that one day, we get 1 million crashes because their DNS can't resolve, right? Things that you think are constant, like Microsoft.com and stuff, right? These things disappear. And same thing goes with XML parsing. You might be pulling something down from months after months after months from a website that you think is stable as. Someone does a tweak, changes the format slightly, and down you go. XML and HTTP are the two big ones, right? They really hit most applications to the extent that every single XML call, every single HTTP call should be protected, right? Now, there's a philosophy around granularity to do with catching. Specifics is the key. Code in a way that you know that something's going to fail. If you read all the MSDM documentation about common functions that Microsoft provides, we give you the exceptions that it fires in the MSDN docs, right? Have catches that do appropriate things. The danger with system.exception is you are going to catch everything. And so sometimes if you have a much more function after function after function approach, you may swallow something up that was more appropriate to be swallowed up higher, right? A more endemic issue. Saying that though, unfortunately there's some APIs, like particularly XML, that will throw system.exception instead of XML exception in some scenarios, right? So sometimes you have to, unfortunately, accept that truth. So let's bring up an example. The Windows 8 application samples are fantastic. There's about hundreds of samples in that folder, and the code is really good, and it does cover a lot of scenarios really, really well. And I really suggest if you haven't downloaded the app samples, just type Windows 8.1 app samples. It's a big download. It's like a 400 megabyte zip file, which unzips to hundreds and hundreds of examples. Grab it. So this is the XML one. It shows you how to do XML parsing. If you load it with this thing set, it goes all red. Well, that's because it caught an exception, right? This one is successful. This one is unsuccessful, right? So this is an example of the code behaving in a very clean and oops, no, it's a very clean way. But if we just damage this and take out the try catch, and just throw this away, where it's catching the exception. Now this is catching as a system.exception, right? If I change that to a system.xml exception, it would miss it. It's not what's being thrown. It's actually throwing a system.exception. Unsurprisingly, if I get rid of that, no, one too many. If I get rid of that, do the same thing again, this time, boom, right? Now, this is being deployed because I ran it once. If you are trying to debug someone's machine and just want a quick dump of, if somehow they contact you and you more like an IT pro environment, like enterprise, and you want to try to work out what's going on, a very quick way of doing that is to use a tool called ProcDump. ProcDump is a sysinternals tool, which I actually happen to write for Marko Sinovic. And it's able to catch exceptions. And there's a command called procdump -ma-i cdumps. This is the folder to put it into. So give me a full dump and install it as the postmortem debugger. So you know when you're at your desk and something crashes, the Visual Studio one pops up and says, do you want to choose your debugger? It's that subsystem. It's called the ADebug postmortem debugger. This is becoming that provider. I'm not going to press enter because it might not. I know it's configured right. So let's crash something. Actually, we'll crash that. We'll crash the XML one. And oops, I broke into it. Oh, yeah. So let's crash that XML app. Now, what's going to happen this time is instead of it obviously breaking into a nice breakpoint in Visual Studio, I'm running it just raw like anybody would out in the real world. It's going to crash. You're seeing it's all frozen right now. And in the background, I made a dump file. We can then open up that dump file, and lo and behold, there is a stack, which doesn't help as much, and do a bang DSE, and then you can see it crashing, and then the H result of a bad XML parse, and that will be a XML-specific error code. So a very quick way of gathering what went wrong on someone's machine and taking it back and analyzing it. So, I mean, to sum up, it's like null reference, right? Put try catch in, and everything's going to be great.
Oh, hang. So next, this is the hang I promised we were going to talk about. So just to make sure that everybody's on the same page again, background tasks work for Windows Store apps when something needs to be done when the Windows Store app is either suspended or terminated, right? So Windows Store app, if the app is not on the screen, does not have any pixels on the screen, the PLM, the Process Lifetime Manager, will soon suspend your app so it doesn't consume any CPU, doesn't burn any battery, etc. If you have, however, an app that needs to do some work in the background, then you can write a background task that then triggers off of a whole set of different system events that you can subscribe to. So, for example, you can trigger off, well, a timer, network connection arrives, incoming packet on a socket arrives.
Notification events.
Notification events.
Yeah. Time zone.
Time zone. User logging in, logging off. So anyway, there's a whole set of triggers that you can start a background task with. Now, the issue here is that a background task, we want to make sure that we understand that the background task is there to do a little bit of work for an app that is not running. But again, we want to make sure that we don't burn too much CPU and be somewhat cautious with battery life of your app. So background task is only a small quota, right? A couple of seconds every hour or so, a couple of seconds of CPU time every hour.
And also a low amount of bandwidth on the wire.
Right, so because NICs are typically very power hungry, you want to limit how much bandwidth they use on the wire too. Now, the flip side of this is, if I have a background task, and I want to make sure that it's only designed to run for a small amount of time. If I don't do anything, if I basically set a timer in my background event, or I make, for example, an outgoing call on the network and the server does not respond and I don't have a timeout, well, then my background task is not doing anything. I have the process is up, there's a background task host process that's up, that's running my background task, but I'm not burning any CPU, so that the infrastructure is then looking at the task and says, well, why are we up in the first place? Well, at that point, the system comes in and says, well, we did this background task, it's not doing anything. It should only run, do a little bit of work and then get out so that I can tear down the process. If you're not doing anything, you're hanging. So at that point, the system will call a cancellation event on your background task, so that you, as a background task, have a chance to clean up, save your state, etc., and then tear you down and create a dump file.
The other time it happens is when in 8.1, when you enter quiet hours, we cancel all background tasks. And so when we released 8.1 with the quiet hours function, we saw this rate go up because background tasks weren't being canceled as frequently in 8.0. And so be aware that quiet hours affects background tasks.
So there's then a couple of things that can go wrong. It mentions here completing a deferral. If you look at this really simple background task, it's a WinMD component, WinRT component that you write. You basically implement this interface background task that has one method, run method on it. You get a task instance passed in that has some properties. And basically what you would do is, in that task, well, you execute whatever you need to do, right? You make a web service call, you want to update a tile, whatever work you want to do in your background task, you do this in this run method. So there's a couple of things, again, that can go wrong here. So the first thing we do is we get a deferral, and the deferral basically means, well, there's the next line somewhere in this function call, I'm going to make an async call. So even if I return from this call, don't consider my background task being done. If I return from this run method, I'll tell the system when I'm done, because otherwise the system will tear me down, right, after it returns from run. So I need to ask for the deferral so that I can make that async do something async call. When I'm done with it, making that call that do something async, then I can complete my deferral. Now, there's an issue here. Anyone see an issue here? Yes. What happens if I throw an exception in my do something async, right? Something went wrong on that network call or whatever. I never complete my deferral. And basically what happens then, I never complete the run method, the system never thinks that I'm done, and I have a hanging background task. Another thing is here that's missing is, suppose that do something async really takes a long time. The server is really slow, takes 15, 20 minutes to come back. At that point, as mentioned a couple of minutes ago, the system notices that my background task is not having any, burning any CPU, and it says, well, you're not doing anything, so I'm going to tear you down. If I have some state in here that I want to save, I don't get a chance here, right? So not having a cancellation event handler does not allow me to clean up nicely when the system tears me down, in case it thinks my background task is hanging. So here's the improvement. We added the background task canceled event handler for the background task, and we moved our complete over to the finally block. So just to make sure that you can see what I'm talking about. Here's my background task. Normally when I run this, see, let's prep this with the task manager. You can see what's going on. So here's my background task. Let me register. So at this point I have registered a background task, and now I can fire it from the IDE. I trigger, and you'll see here that progress here, 20%. Now, in Task Manager, you see this background task as a background task process, right? So this is background task host.exe. When my background task completes, the run method is over, it's through, you see that the system tears down that background task host.exe. What happens if I don't complete that deferral? Well, you guessed it. It's still registered. I trigger. It starts running. You'll see that my background task host process is up, and it's still up. And if my demo goes well, it will stay up, because again, the system does not know. This is actually a thing we saw a lot of these hanging background tasks, and especially for this reason, a leaking deferral. If you have a deferral, you make that a class member variable. So not here in the method itself, but upgraded to a class level variable, and then you don't complete that thing when you're done. You leak that deferral, and the system never tears you down. And then we get a dump file that then Andrew will look at.
Which is very, very empty, because your run has completed, right? So all we have left is the background task threads and no evidence of what program was inside it. And so we go, that's another million today that we couldn't do anything with. And so it's up to you guys to fix it. We can't even give you a report on this, because it came back to us and all it had left was our code. Right? All your code's come and gone, right? And so we're trying to instrument, trying to work it out, with clever analytics internal to debugging, but we don't have your symbols, right? And so we can only go certain amounts through assembler and stuff to work out who did what and who's to blame. So this is one of the ones where it's all on you, right? We can't solve this one for you, right? With crashes, it's deterministic. We can send a report, we can harass you, we can phone you, we can do that stuff. When it comes to this guy, we're out of luck, unfortunately.
But one little note here. It is, by the way, arguable why you want to use a deferral here in the first place. The await here, normally you would have an await to offload the thread, right? Because, well, there's a UI thread that you want to keep pumping messages. Background task, by definition, there is no UI involved here. So if you can write it, do something async differently, so that it's no longer async, there's no UI thread you tie up. So then you can get rid of the async, the deferral, and the await altogether.
You
Makes it
still
a
have
little
to do
cleaner.
cancellation.
What's that?
Still have to do cancellation.
Still have to do cancellation. Yes.
Yeah. You have 5 seconds to respond to the cancel, otherwise we still will kill you. And that particularly happens at quiet hours. So when you do your call, so you have a cancellation handler, that's fine. All you're doing is sending a Boolean on your class so that every time you go around a loop or something, you're saying, hey, am I still meant to be running? The other side of a cancellation handler is you need to make a cancellation task and associate that with any awaitable call. So like if you have a web call or parsing in some document or reading a file, add a cancellation handler to the end of it and add that cancellation token. And that way, in the cancellation handler, you'll say to the cancellation token, cancel, and then that will fire an event way down in that asynchronous call, and it will bubble up as a cancellation exception, right, which you have to catch.
Okay, last one here, frame get navigation state. This is an interesting one. So I have a, let's demo this. It's more helpful. I have just a really simple, straightforward app, stock template, didn't do anything with it. It's one of the templates, 2 pages, can navigate between them, etc. Now, the suspend and resume mechanism, you know that, well, when your app goes off the screen, then after a couple of seconds, the system will try to suspend your app. It will send you a suspend event that you can use to save state. And the only reason you use that to save state is because, well, if the system terminates you, because there's memory pressure or some other circumstances, your app can come back to that same state where it was in before your app got suspended, right? So this app, for example, if I now do again here under suspend, I do a suspend and shutdown, what you'll see, if I now bring it back up, it has saved the state and it knows where it is, and I should be back in my secondary page, so I'm not in my home screen, but I'm in my details page here, with that same backstack saved. So far, so good. This is all working, of course, as it should. Now, what happens if I, in my navigation helper here, save state, if I save some state here in the page state that the serializer can't handle. Oop. So I just saved some dummy data, an array in my.
You can make that a bit bigger so we can see it. A bit better. There we go.
I saved some state here. So when you navigate between pages, navigate from, there's this navigation helper that helps you when you navigate between those pages to save that state in this page state variable here. Now, the fascinating thing is that when I just run my app, I can just run it and it will handle all this just fine. If I test my app like this, and I now shut it down or don't do anything else, then I will think that my app is working just fine. However, if I do the same thing, suspend and shut down, you will see that you get this exception on this suspension manager. And basically, if you set a breakpoint here and you debug it, you'll end up in that same save state where I was before, on the split page, and it tells you, hey, the serializer can't handle this data. It's a little nasty because you don't get it when you test your app without going through this suspend and shutdown. Note also that we can catch it in automatic testing in our WAG tool for that same reason, right? You have to do some work, you have to navigate, and then get some state in that page state that we can serialize later. So this is one we saw frequently as well.
So if you're a COM-type programmer, this will give you a bit of the sausage within the sausage factory. This just gets converted into a variant, right? Internally, it's just a variant. When we have our own serialization system, and it just gets turned into a variant. And if it's not an intrinsic type in a variant, so roughly anything that's not pointer, we can serialize it. So that brings you down to GUID, numbers, and a string. And anything else, anything that has a star on it, anything that's array, all of those are not supported, right? So think of it as absolute basic intrinsics. It is very disappointing. And what's worse is the guidance is a bit two-sided. We support this. We support full complex serialization as long as you don't use the serializer that we default add to your project. Right? If you write your own serializer, you can put anything you want into it. Our basic implementation is just, as you say, disappointingly too basic. Yeah. Now what's worse is, if this is a Java program, close to impossible to understand what the dump file means. It's so far away from the code to do a serialization that it's very hard to correlate the two. Yeah.
Okay, I think we have arrived at the end.
Yeah. So there was a couple of blogs on the way. This Improving Apps with Quality Reports blog was released in 8.0, explains how to debug with 8.0. This debugging Windows 8.1, I wrote about 8.1 debugging with Stored Exceptions version 1. And the last one was to do with Stored Exceptions version 2. And here's our books, here's our TV shows. I highly suggest you watch Defrag Tools. Defrag Tools, as much as I host it, is about the only thing on Channel 9 that goes to a 400 level weekly. Right? We tend to be more marketing and 200-300 level type stuff. Defrag Tools' goal is to only be 400. Some weeks we don't get there, but that's the goal. So if you want to learn, really deep dive into things, do that. If you have any questions ever, and I mean ever, email defragtools@microsoft.com. It comes to me eventually, and we will look into any issue you have. We are fully engaged in helping you guys get past your crashes, your hangs, and also your performance issues, which is a different topic. So feel free to do that. Buy his book, it's awesome. And if you need bigger help, endemic enterprise level help, get a support contract. Thank you for your time, guys. Have an enjoyable last session, and a good flight home.
Where's our session rating thing?
That's on your ticket. Don't they do it? No, anyway.
Oh well, no QR code.
Yeah, go for it. So the CLR exception is fully packed. So you can make your own CLR exception. So if you know that you're in a certain area and you want to make sure that certain payloads are there, what you could do is in an unhandled exception filter around your whole app, say, right, this is the additional information I want. Except that you had something bad go on, capture it, make an inner exception of that original thing, and then pack it into your specific one. All of the properties of that CLR exception and all its ancestors will be in its Stored Exception version 2 dump file, which is March onwards. Version 1, can't promise it. It was more of a luck thing rather than a deterministic thing. But yeah, put something around the whole thing. If you are in that situation that you know you're going to go down, don't go down. Pop up the error message. Well, one of the things I suggest to do is phone home. Don't phone Microsoft to get it later. Send a call to a web service at your website or something like that and send a report to yourself, right? Because you're still stable at that point in time, right? You still have a full WinRT to call. Send the telemetry to yourself, say, I got this, serialize the CLR exception out to a stream and send it to yourself. Well, the privacy policy says that you can do that. Roughly, if you have internet, Yeah, there's a balance here. It does, you're right, it does come down to the app. But if you pack it into a CLR that is reported to Windows Error Reporting, the NDA that you've signed by going to the store signs the NDA for the download, and then we always make sure that the information is suitably PII stripped where we can, and the NDA you signed, roughly NDA is the data that you've purposefully brought up. Yeah. There's a balance between, and it's also size, right? We can't get millions of dumps a day at 50 meg each, right? So there's a balance. But good question, yeah. Well, as of like 3 or 4 months after 8.0 came out, we moved to stow exception only based packing. We don't actually, store apps will only ever emit a C0027B now. We will never emit anything like a normal old error code, like a desktop app would have. So they always were version 1, and I've been analyzing these for 18 months, and they've been hard to analyze, and so we pushed through additional telemetry on version 2, which came out in March, to make the debugging better. This works with triage dump files. These things are only 64K, right? They're tiny files, but you can get that far debugging, which is pretty impressive, really. So I'm not sure if that answers your question, but you'll always get a stow exception. The string you see on the dev portal actually is the string that I wrote, so you can blame me for it being so long and cryptic. That's what comes out of Bang Analyze, that we crunch it down to a single phrase that represents the bucket or the failure curve, and then that's what you see on the screen. Unfortunately, all the detail that's differential is on the far right, and it gets clipped on the website and goes ... so you can't tell the difference. We know it's bad, and we're working with the store team to get that fixed. But the thing is long. It's like 400 or 500 characters long, so there's a limit. With the unification of the store, there's the unification of dev portal, so the phone and Windows is more unified. And so you'll see consistent reports. And then as Xbox comes online, that will be there as well. So, did that answer your question, Grana? As I said, seriously, if you have questions about WinDBG, I know it's a rare topic, and for anybody who's interested, people at Microsoft are willing to give you our time, because we know it's a really powerful tool that's underappreciated, but it's a really, really good tool to know. So if you have questions, feel free to email anything, as simple or as hard as you like.
I'm looking for the barcode. It's not, they didn't put it in.
Yeah, I don't know why.
The QR code.
Yeah.
Yeah, this was easier, but sorry.
Yeah. All right, thanks, guys. Have a good rest of the conference. Yeah.
Thank you.